Good morning, everybody. Hopefully you guys are doing well. Let's start with some green check marks and make sure everything's working today. So far this morning, there have been no major catastrophes in our studio, which is always nice. Nice way to start the day. Looks like a few of you have picking up everything. Good way to start. I want to talk a little bit about a final exam. Then I'm going to cover some problems relating to the sine and cosine ratios, and then I will set you guys free for the day. So those are kind of the three things we're going to cover. Looks like a few people, the check marks are slowly coming in. Just give everybody a second, make sure everything's working properly. I think we're okay. All right, so I know we have a provincial final exam, meaning that at the end of the semester, the Ministry of Education is going to make an exam. They're going to administer it to you at Central, and that's going to count for 20% of your mark. We also need to do a final exam kind of in class, so not the provincial. You can call it midterm number 2. In the course, it's called final exam. So kind of like a second midterm. And we've scheduled a date of Monday, January 18th. So not Monday coming up, but the following Monday, so January 18th. And that's going to be held at Central Gym, just like the first midterm we did back in September, October, like October, November, in the middle there somewhere. You guys are going to come in. It's going to be mainly on the material from chapters 5, 6, 7, and 8. And there'll be a small portion of questions from chapters 1, 2, 3, and 4. And I mean, if you have something going on, Taylor, I'm sure we can make arrangements. You're right at the coast anyway, so things are a little bit different than you. But if you're local, Monday, we will be in the Central Gym, 9 a.m. And just want to point out a few things within the course. So in the course here, we have Unit 8, and down at the very bottom of Unit 8, we're going through the Unit 8, we're kind of working our way through it. We have today and tomorrow left for that. And then at the bottom, there's this final exam. So you can see here it says complete and submit review package. Final exam is about 25% of the material from units 1 to 4 and 75% of material from 5 to 8. And it's going to be 2 parts again. You're going to have the first part is multiple choice, and then the second part is just going to be long answers. So I have sort of 2 documents down here. One is final exam topic study guide, and the other is a learning guide for the final exam. So you just go in here and download the assignment. So let's just take a look at those real quick. I have them loaded into my computer here. So the final exam review learning guide, just like every other learning guide we've done, a bunch of questions. So you think about sort of timing. I'm going to finish up Unit 8 tomorrow, and then maybe do a review day on Monday if you like. Then you have a full week before we'll have your final exam or midterm number 2 at Central on Monday the 18th. So there'll be plenty of time to do this coming up. I know I'm still working through Unit 8, and there's questions on the review from Unit 8, so it's kind of doing 2 things at once. But I just wanted you to be aware it's there. If you want to download it and print it off, you can. And all that stuff's there. So you can see that it has some stuff from the very beginning. So radical, SI system, real number system. Number lines, all this sort of stuff, square roots, adding, subtracting radicals, multiplying, dividing radicals. There's a measurement section, volume, surface area. So the learning guide doesn't have everything on it. I mean, there's going to be some stuff that isn't there. So just be aware that it's not kind of inclusive of everything we've done. It's just kind of snapshots of parts. So you got polynomials. And then we went to graphing. You have some graphing stuff. And then you have lines, which we just finished. And then linear systems, solving linear systems. and then finally trigonometry, which we're currently working our way through. So it's 10 pages long, so it's the length of a normal learning guide, although it's composed of questions from the entire year. So like I was saying, don't think that, this covers everything. I've done this learning guide. I've did really well on the learning guide. I'm completely prepared for the test. Well, yeah, a lot of the stuff that's going to be on the test is in the learning guide, but there's lots of little things that aren't in this learning guide that'll be on your final exam. So I also just made this little kind of sheet today. Final exam topic study guide. Now, you don't really necessarily need to use this for the in-class midterm number 2 on January the 18th. But you will want to definitely go through this for the final exam, the provincial exam. So what I've done is I have looked at all of the units that we've covered, so 1 through 8. I've looked at all of the lessons and then written down the topic. And what I would like you to do eventually is, doesn't need to be done like this week, maybe next week sometime. I want you to go through each of the topics and just, it's as easy as printing this off and then checking it off. So the real number system. What is the real number system? I don't remember, or, oh yeah, I need to review it, or I've mastered it. So if you remember the real number system, oh yeah, we had rational, irrational, we had natural numbers, integers. Yeah, I remember all that stuff. I'm good with that. So you just put a little check mark next to mastered. Or maybe you're like, well, I kind of vaguely remember. You flip back to it, you look at it, you're like, okay, this is starting to, come back. And then maybe you just want to review it. Or if this was possibly one of the topics that we covered that you just had no idea about, you need to go back and relearn it. So you could put something there. If you want to put a note like, I missed this class, or whatever, you can write a note in there. Now, I said this last day or 2 days ago, and I'll say it again today. The final exam is totally up to you. As of tomorrow, essentially, I've delivered all of the material that's going to be covered on the final exam and the provincial exam. So you're going to get out of studying what you put into it. If you just kind of waltz into the provincial exam, don't really do a lot of review, and just kind of hope for the best, well, your mark's not going to be great. It's just a reality. And if you put some time in, you're honest with yourself, you're looking at this sheet here, and maybe you're on unit 6, and you're like, parallel and perpendicular lines. Oh, I really don't remember how to do that, so I need to definitely go back and learn that. Then, you're going to have to go back and learn it. And if you are kind of kidding yourself a little bit by saying, hey, I kind of remember that stuff, and, whatever, I don't really feel like relearning it. Well, there's going to be questions on the final with that stuff on it. You're not going to do well on them, and that's just the reality of it. So you just need to kind of be honest with what you need to relearn, and it's a kind of a habit for students to go and, you did really well on maybe solving linear systems by graphing, and then you're like, oh, I remember how to do those questions. So you're going through the review and you're doing all the linear systems by graphing questions, you get them all right. Well, you just spent some time studying something you already knew how to do. So I'm not saying you shouldn't go over some questions that we've done in the past, but I'm saying concentrate on spending the time on the stuff that you need to refresh your memory on, or stuff you didn't really learn well the first time. You'll be amazed now that you've made it through the entire course, how much stuff that you learned along the way that you kind of didn't understand fully or didn't get at all. You go back and look at it and you'll be like, wow, I can't believe I didn't understand that. It's such an easy concept. So some of the learning we've done along the way will help you in previous stuff. So Abby's asking, do you want us to hand this into you? I think I would like you to hand it in. I'm not going to get you to hand it in today or tomorrow, or maybe at the end of next week. I just want you to go through it, all of the course, and just kind of look at areas where you need to focus your studying. So I just wanted to get all that kind of review-y stuff out of the way. So kind of two things. I know a few of you are late, and that's fine. It's all good. Number one, we have a second midterm on January the 18th, which is a Monday, 9 a.m. at Central Gym. So just like the one we did a few months ago and like the English one you guys just did before the break. Same deal. The material will be about 75% from units 5 through 8 and about 25% from units 1 through 4. It's, I believe it's like 35 or 40 questions, like maybe 35 multiple choice and like 5 written. I haven't actually made it yet, so I don't know what it's gonna look like. So maybe mid next week I'll have it made and I'll be able to tell you exactly how many questions it has. But multiple choice section, written section. That's kind of how the breakdown's gonna look. And it'll be really similar to the last one you guys did. I am making it myself, so I'm gonna try to pick questions that we've covered in class, not stuff that's kind of out of the blue, nowhere you've never seen before. And we'll go from there. So that's the first thing. The second thing is this little sheet, final exam, topic study guide. Just has all the lessons we've done throughout the year. You, at some point in the next few weeks, should go through it and say, oh, okay, I know this, don't need to know this, or, you know, need to review it, or, you know, I'm really good at that. Taylor, that's in the course. So if you're in Unit 8 in the course, just give a second to load. So you open up the course and you go down to the very bottom. This is in Unit 8, and at the bottom of Unit 8, there's a little final exam section here. And at the bottom of the final exam is the topic study guide, and then the final exam review package is kind of like the learning guide for the final exam. When it says final exam, I'll refer to it as midterm number 2. It is a final exam essentially, but I don't want you to have this kind of, you know, final exam just kind of sounds scary. It's just a midterm. It's just some, you know, stuff from the last few units we've done. So that's all in Unit 8 in the course. I put at the very top, I did this yesterday, and I'll update this with the test, the midterm exam date and location. But there's this little blurb I put in here. I've mentioned it a few times, but I just want to mention it again. If you have done a unit and you weren't exactly happy with your grade on the test, or you just want to go back and redo some material, I've opened up an invitation for you guys to rewrite any of the unit tests you want. I'm going to try to limit it to maybe 1 or 2. I think I said 2 before the break, so I'll let you redo 2 units. I need you to provide me with some evidence that you've studied and you've relearned the material and you've maybe made some corrections, or you can explain to me how you know, you've learned along the way. If that means going into the course, for instance, if you really struggled with Unit 8, I know we've just recently done Unit 8, but if you go into the lessons, give this a second to load, allow that. All of the lessons have these practice assignments, which are just a bunch of additional questions that we didn't cover in class. So if you wanted to go back and maybe do, you know, some of these questions, I know it can be a lot, but if you really struggled with like lesson 1 and you went back and you did all these questions, you say, hey, Mr. Borden, you know, just, you know, send it off to me by email. These are the questions I redid. I really didn't understand it when we did it in, you know, September, but now I've spent some time relearning it, and here you go. And then I'll just send you another, I'll open up another attempt on the test, and you can redo it. If you want to think about it as improving your grade, that's a great way to improve your grade. And yeah, if you just want to redo a test just for the sake of looking at the material again, by all means, let me know. And then that's a good question as well. So what mark do you think we have gotten in order to need to redo the test? It doesn't matter what the mark is, Abby. If you got 19 out of 20 and you just want to go back and do it again, you know, maybe you get 17 out of 20, I'll give you the higher of the 2 marks. I'm not going to deduct marks because you redid something. You know, you're going out of your way to redo something. I'm not going to, you know, take marks away. So it doesn't matter. I mean, if you got, you know, 5 out of 20 and you want to redo that, awesome. If you got 20 out of 20 or 19 out of 20 and you want to redo it, that's fine as well. So I'm not going to put a limit on it. If you are going out of your way to do work and try to relearn material and showing me that you're doing that, then that's great. Avery's asking, is it worth it to redo quizzes? No. Each quiz counts for less than 1% of your grade. I think it's like 0.3% per quiz or something like that. So it's just really not worth it. I mean, they are there as an indication to me and you kind of how you're doing on each of the sections, but they're definitely not, they don't add up to that much of your grade. I think quizzes work out to like 10% of your grade, and we wrote, let's think like 3 or 4 quizzes per section. It really doesn't work out to be that much of your grade. If you're really upset with your quiz score, you got like 1 out of 5 and you just, we're having a bad week and it's bothering you, I can open another attempt. But in terms of your grade, it's not really gonna affect it that much. But if you want, you can. It doesn't matter. Just email me and we can figure something out. All right, I think that's it. In terms of the chat, I'm gonna jump back to the questions that we were gonna talk about today. So overnight, I asked you guys to watch the video on I put the sine and cosine ratios together in one video, and I said we'd spend some time today talking about some questions regarding the sine and the cosine ratio. Now, before I get started, I want to, it sounds kind of silly, but SOHCAHTOA, it was something I described in the video, and it's really a great way, an acronym, or I guess it's an acronym, for you to remember the 3 trig ratios. I don't think they're on your formula sheet. I'm gonna have to double check on that. I'm pretty sure they're not. If you want to throw some questions into chat, I can definitely go through them. So the acronym is SOHCAHTOA. I'll just write it down like this. It's not an H. TOA. SOHCAHTOA. I will say it a lot over the next 2 days. And what SOHCAHTOA means is the S from so is sine, and then the O and the H is the opposite divided by the hypotenuse. So there's your O and your H. Ka is cosine, is the adjacent. Second H kind of looks like over the hypotenuse. And TOA is the tangent ratio, is the opposite over the adjacent. Great way to remember let's color code it. Great way to remember the 3 trig ratios that SOHCAHTOA, that we've learned here. So you'll use this for your whole rest of your math career. It's something that just it's a great way to remember them, a nice little easy way. Reading a question here. Do you know, I found the sine and cosine sort of confused. I don't understand why we use those instead of just using tangent and switching the opposite and adjacent. Okay, so that's a great question, Abby. Sometimes the information you're given won't allow you to use the tangent ratio. So we'll look at a few examples and I'll try to point them out as we go today. And you know the 3 ways to write linear equations will be on the formula sheet, like y-intercept form. Yeah, so the slope-intercept form, the slope-point form, and the general form are all on the formula sheet, but they are not labeled. So it doesn't say this is the slope-point form. It just has the general slope-point form, or the general slope-intercept form, or the general form. So it's all on there, but it doesn't specifically explain which one's which or anything like that. So you just kind of need to know the difference between them. I guess they're all there. We'll look at that perhaps a bit later. I know, it's kind of handy to have all that stuff there, isn't it? Okay, SOHCAHTOA is quite handy. Yes, SOHCAHTOA is your friend, especially on a test or a final exam. So right now, we've broken down all the sections. use the sine ratio to find this, use the cosine ratio to find this. But when you get to a test or the final exam, it's just going to say, find the missing angle or find the side or solve this problem. And you're going to have to go, okay, I need to figure out which trig ratio I want to use, sine, cosine, or tangent. So you'll see it more in the last section, the third section, or I guess technically the fourth section that we do. They're all kind of like diagram type problems with two triangles, and then you'll have to know which one to use. But for today, and I can see why you'd kind of be confused by that, there's really, it just says use the sine or use the cosine, so it's kind of guided at the beginning. Okay, let's do a little warm up here, make sure everybody's calculators are in good order, and we have our calculators in degree mode, not radians or, I always forget the other one. Anyways, never use it. So what is the sine ratio of the following angles to 4 decimal places? The first one is 19 degrees. So all I'm going to do, my calculator, I'm going to press sine, and then 19, and then hit enter, and it's going to give me the ratio of those sides. If you're in degree mode, you should be good to go. So the sine of 19 degrees, the ratio of those sides, if the angle is 19 degrees, is 0.32556. So 325, we round those last one up to 6. So if you could plug that into your calculator, make sure it's working, that would be awesome. Not that your calculator would break, but just to make sure that you're in the right mode and everything's kind of going along well. And Alex, no, I didn't look up Klein bottles. I'm sorry. I had lots of stuff going on yesterday, maybe today. Now that you've asked me twice, I feel obligated. Okay, nobody's kind of waving their hands wildly and saying, mine didn't work, mine didn't work. So I'm going to assume we're okay with that. Let's do the inverse. So in this example, we're given a ratio of side, and we want to kind of work backwards and figure out what the angle is. So the first example, 3a here, we're given this little box should probably have a theta in it. Just kind of a formatting issue. Still don't know why it's going on, but it is. So when we want to find the angle, anytime we have to determine the angle, we're going to have to use the inverse sine. Or on your calculator, that's going to be your shift and then sine, or your second button and then sine. So on my calculator, I'm going to go shift sine, because mine's forwards, 0.3428. And it goes, in my calculator, gives me 20.04 degrees. And it says rounded to the nearest degree. So this would just be 20. And then we put the little degree sign up next to it to remember that that's an angle. Perfect. Just like I mentioned last day with the tangent, I have also loaded in sine and cosine table here. So just to kind of dispel some of the mystery surrounding this trig, it's taking two side lengths, dividing them, and then you get a ratio. That's it. The difference between the tangent and sine is now we're dealing with the opposite and the hypotenuse instead of the opposite and the adjacent. So we're just dealing with different sides in the triangle, but the principle remains the same. If I were to go back to let's go back to the learning guide here. I had a 0.3428. I'm going to go to my sine table and find 0.3428. So here's 0.3420, and this is 0.35 here, so I don't want that one. I apologize for that being so small, but it's just the only way I could get it on there. So it's going to be about 20 degrees, and that's what we found using our calculators. So you could absolutely do every one of these questions without using a calculator. You kind of run into some rounding issues, and if you were to have done trig 30, 40 years ago, before pocket calculators were really popular, you would literally have used a trig table. There would have been a sine, cosine, and tangent table. And that's what you would have used to do these questions. Now we just have calculators that have these tables entered and they're really accurate and they have lots of decimal places for us. But it's just, referencing a table. It's just referencing ratios of sides. So students just get kind of overwhelmed by it. They plug it into their calculator, it spits out a magic number at you, and you're just like, wow, this is amazing. My calculator is so smart. No, it's not. It's just using a table. Like it's not doing any magic or anything. So just consider that when you're going through these types of questions. All right, so we did that one, 20 degrees. That was pretty good. We're happy with that. Hopefully you ended up with 20 degrees. And without the table, we couldn't do math. We could. It's just the table has all of these sort of values, entered for us. It'd be kind of like saying, without a multiplication table, we couldn't do math. Well, you could. You could work it out if you wanted. Like 28 times 12. Well, if you had a really big multiplication table, you could just look up the answer in the table. Or you could plug your calculator, because all your calculator is doing is just referencing a big multiplication table. And you could actually find the ratio of the sides and do some calculations and find it that way. But it's just said, it's kind of taken a few steps out of the calculation process. It says when the ratio is, for the tangent, if the ratio is 1, well, then you have 45-degree angles because it's an isosceles triangle. It's just, all these values are preloaded in there. So you could do it if you wanted without a calculator or without the table. It's just a bunch of values that are pre-entered for you. Just kind of speed up the process. Let's look at number 4 and 5, and then maybe I'll leave the similar type questions for the cosine down below. So given the following information, find the unknown side to the nearest tenth. So you can see number 4, you're asked to find the unknown side, and number 5, you're asked to find the unknown angle. And remember, when we find an angle, so for number 5, we must use the second function or shift. Depends on your calculator. So number 4. The first thing we need to do is identify where our angle is and label the sides of our triangle. And I'm going to do this for every single question I'm given with a missing information. So it looks like the angle we're given is 42 degrees. We also have the 90-degree angle, but we're not concerned about that because all of the problems we do in this section must have a 90-degree angle in it. So we're just going to ignore it because it doesn't really have much of an effect on anything. So if I label my sides, the longest side of my triangle is the hypotenuse, which is across from the 90-degree angle. So I'm going to call this my hypotenuse, or hype. I always like to label the opposite side next because it just makes the most sense to me. So if I start at my angle here and I go opposite my angle, that makes this 6. My opposite side. And then that leaves one side, which must be the adjacent. And remember, the adjacent side actually helps form the angle with the hypotenuse. That's what the adjacent side is. So there we go. I've labeled my 3 sides. Now, Abby asked a question kind of around this sort of idea a little bit earlier. Pretend we didn't know we were in the sine section of the learning guide, and we look at the information we're given. Well, what do we know and what are we trying to find? For all of these trig questions, there's 3 pieces of information. You're either going to be given an angle and a side and asked to find another side, or you're going to be given 2 sides and asked to find an angle. There's 3 things always. You're going to be given 2 of them and be asked to find the 3rd. So in this example, things I know. I know the opposite side has a length of 6. I know the angle I'm given here is the 42, and I know I'm trying to find the hypotenuse. So what 3 things am I given? Well, I'm given my opposite and my hypotenuse. It turns out that I don't need to know anything about the adjacent, nor is it given to me. So in this particular example, I don't really need it. I don't have it, I'm not trying to find it. So I'm not dealing with the adjacent side. So if we think real quick of our SOHCAHTOA, SOHCAHTOA. What sides do I have? Well, I have the opposite and I have the hypotenuse. So I'm using my trig function sine. I kind of just eliminated the adjacent side here because I didn't need it. So you can see that both cosine and tangent, sorry, I circled the wrong letter, cosine and tangent both include the adjacent. And I decided I didn't need it and I didn't have it. So what am I doing? I'm using the sine. Okay, what is the sine ratio? Well, the sine of an angle, whatever that angle is going to be the adjacent side, the length of the adjacent side, divided by the length of the hypotenuse. Okay. Perfect. I have my angle. In this case, this 42 degrees. I can plug in to where my angle is. I wrote the wrong thing. It's just not a good start here. The opposite over the hypotenuse. I'm sure somebody was about to correct me on that. I also know the opposite is 6, so I'm going to plug that in here. And my hypotenuse, I don't know, it's x. I'm going to plug it in down there. So here we go. I have the sine of an angle, in this case 42 degrees, is equal to the opposite side, which has a length of 6, divided by the hypotenuse, which has a length of x. I don't know what it is, but I want to find it. So we're trying to find x. Or if you want to think about it, solve for x. So we need to do some math, some algebra to get that x by itself. Now there's lots of different ways to do it, and you'll kind of work out ways that work best for you. But the way I did it yesterday was this. I said, okay, the x is on the bottom. I want to get it to the top. I'm going to multiply both sides by x. If I multiply this side by x, I get x divided by x just gives me 1. And then on my left side, I have x times the sine of 42 degrees is equal to 6. Okay? Now I'm multiplying the x and the sine of 42. So the opposite of multiplying is dividing. So I'm going to divide by the sine of 42 degrees on both sides. And remember, the sine of 42 degrees is just a ratio of sides. So over here, it cancels out. I get 1 on my left side times x, which is x, and I get 6 divided by the sine of 42 degrees. Now, most of you probably have calculators that you can just plug everything into and it'll spit the right answer out at you. So you can go 6 divided by sine 42 in your calculator and hit equals, and it's going to give you an answer. If I just take a quick look at my sine table, 42 degrees is 46, 43, 42. So 0.6691. All right. So I have x. Let's try a black pen instead of yellow. X is equal to 6 divided by, I've already forgotten it, sine of 42, 0.6691. And then I'm going to just do the calculation. 6 divided by 0.6691 is 8.967. Now it asks the nearest tenth, so I'm going to get 8.9, and I'm going to have to round it up. So I'm going to get 9.0 is the length of that side. If, when you were doing this question, you skipped this step, because you can just plug it right in your calculator to get from there to there, I would be completely fine with that. So if you went 6 divided by sine 42 in your calculator and you ended up with 9, that's fine. If you show this step in the red box here, that's okay too. That's just an additional step. So there you go. It asks to find the length of the unknown side. We use the fact that anytime that triangle has a 42-degree angle in it. Doesn't matter how long the sides are, the ratio of the sides is always going to be 0.6691 when we're talking about the opposite and the hypotenuse. And we could take that information and then end up with our answer of 9.0. Now that's kind of, the first way to do it. The second question here is kind of working backwards. It gives you the sides and asks you to find the angle. So we can look at that and go from there. And just see that Abby, is asking a question. Do you get marks off on the provincial if we don't show our work? No. The provincial is going to be completely multiple choice with the exception of the last 5 questions, which you're going to have to write in numbers. So it's going to give you some boxes, you're going to type in the numbers. So no work is necessary anywhere on the final exam. There's kind of exceptions, and when we start looking really closely at final exams, I'll show you what that looks like. But they'll give you somebody's work, and they'll show you a person's steps, and they'll ask you to find the error. So they'll, if it's like a solving by elimination, and basically they'll give you somebody's steps on how they can solve by elimination, and then you need to find out where the error is. So that's just one of the ways they kind of get around it. Okay, same process as we had in the previous question, except this time we're asked to find the angle, and we're using theta, but it didn't format properly, to the nearest degree. So I'm dealing with the angle. So first thing I'm going to do is identify my angle, which is down here in this corner. The longest side of my triangle is the hypotenuse, and that is across from my 90-degree angle. That one's the easy one to find. And then my other two. I have the opposite side, which is opposite of my angle. Even though I don't know my angle, this is still my opposite side. It's opposite the angle, my reference angle, we'll call it. And then what do I have left? Well, I have the adjacent side, which always forms the angle with the hypotenuse. And it turns out, again, in this question, I don't know the adjacent, and I'm not trying to find it, so I don't really care about it. Okay, what do we have? Well, we have the opposite and the hypotenuse, so I think back to SOHCAHTOA, and I have the sine of my angle, which I don't know, is the opposite length divided by the hypotenuse length, and then I go from there. I don't know what the angle is this time, but I know my opposite side has a length of 9, and my hypotenuse has a length of 16. Okay. 9 divided by 16. Top of my head, I don't know what that is. 0.5625. All right. This is one of these examples where we're given a ratio of sides and we're asked to find the angle. Now, anytime you're asked to find an angle, you have to use the second or shift function in your calculator. Remember, if we are given an angle, I can tell you the ratio of sides. If we go back to the table here. So in this case, we have a ratio, and we're asked to work backwards to find out what the angle is. So 0.56, I'm going to find it. I have 5592 here. So it's going to be 5592. It's going to be really close to 34 degrees. 5592 is really close to that. Yeah, so probably around 34 or something like that. I have to work backwards. So on a table, I just look and it's there and I say, okay, well, that corresponds to 34 degrees. But in your calculator, you need to tell your calculator, hey, calculator, I'm not concerned about what the ratio of sides is. I want to know what the angle that gave me the ratio is. And the only way your calculator knows how to do that is if you hit the second or shift button to determine it. There's also a way that we can write this in the question. So this is kind of like math notation that'll work, that people will understand. So I'm going to clear this out and just continue over here on the side. Okay, so if I'm trying to find an angle, the angle theta in this case, that's the letter we're using, I'm going to take the sine, because I had the sine, and I'm going to write the sine -1, or the inverse sine of 0.5625. That gives me an angle. I said 34. Taylor tells me it's 34.2. I like that. And it asks for the nearest degree, so I can get rid of the 0.2. So this is the notation that you can write. The sign with a little -1, or inverse sign. Remember, anything with an exponent of -1 is the inverse. So that's how we represent that. Or I could have written it this way. I could have written theta is equal to sine -1, or the inverse sine of 9/16. If I hadn't actually calculated what that ratio was, I could have just written it like that, and that would have equaled 34 degrees as well. So those are two different ways to write the same thing. In both cases, you're going to end up with an answer of 34 degrees. So hopefully that is okay. For number 6 and 7, this is two definition type things. We have the angle of elevation and the angle of depression. And I'm not sure I covered this until possibly the next lesson. So I should talk about it now. If we had some horizon or a horizontal line, the angle of elevation is the angle that is going up. So I'm calling this the angle of elevation. So if you had a horizontal line, you measure up from that line, that's your angle of elevation. For number 7, same deal, horizontal line. If you're measuring down from your line, that would be the angle of depression. So there's those two. The lesson in the course uses a good example of with a worm and a bird in a tree. I kind of read it really fast, and I thought the worm and the bird were both in the tree, and I was like, oh, that's not a good example, but I see what you're talking about. You have somebody looking at a bird in a tree, so your angle of elevation would be kind of up from the horizontal, and then the worm is in the ground, not in the tree. So the worm would be underground. Yeah, that makes a lot more sense. Yeah, so that's a great way to think of it. I could draw a nice little picture, but I'm not going to. So that is the sine ratio. The cosine ratio is the exact same process, except for cosine ratio questions, you're going to have, if you think of SOHCAHTOA, Ka is cosine is the adjacent A and H, SOHCAHTOA. So everything in this section is going to be dealing with the cosine of an angle is the adjacent length divided by the hypotenuse length, just based on my SOHCAHTOA. So I'm going to leave those. You should be able to do 4 and 5. Those are just like the ones I did before. So we should be good to up to here, which is the bottom of page 4. So this is lessons 1 at the top, 2, and 3. So we're good up to the bottom of page 4. I would be happy to do number 4 for cosine, Daly. Given the following information, find the unknown side to the nearest tenth. All right. Let's start with our angle, which is right here, 27 degrees. I have the side across from my 90-degree angle as my hypotenuse. If I took that angle 27 degrees and went straight across, this would be my opposite side. And it turns out in this question, I don't need the opposite and I don't have it, so I don't really care about it. What's left is the adjacent side. And remember, the adjacent always forms the angle with the hypotenuse. So there we go. So what information am I given? We're pretending again that we're not in the section regarding cosine of an angle. So if I think to SOHCAHTOA, I'm going to have SOHCAHTOA. And I have, in this case, I'm given the hypotenuse, and I'm asked to find the adjacent. So the adjacent and the hypotenuse are here, so I know I'm using the cosine. Again, the opposite is located here and here. I don't have it, and I'm not trying to find it, so there's no point in dealing with sine or tangent. Okay, so let's continue on. The cosine of my angle, whatever it is the adjacent side length divided by the hypotenuse side length. In this case, my angle is 27 degrees, which is equal to my adjacent, which is x. So just from here, and my hypotenuse, in this case, was 15. Now the nice thing about this is my x, which I'm trying to find, is actually on the top. So I get to do this in one less step than I have in the previous examples I've shown. I have this 15 on the bottom. I want to get it to the other side. So what am I doing? I'm dividing by 15. What's the opposite of dividing by 15? I'm going to multiply by 15. If I do it to one side, I have to do it to the other. So I'm going to end up with 15 times the cosine of 27 degrees is equal to x. Now I could plug this in two steps. I could figure out what the cosine of 27 is and then write it down and then multiply by the 15. Or I could just do it in one step. So my calculator will allow me to do that, and yours will too. Some of you will have to work completely backwards. You have to go 27 cosine times 15 and then equals. If your calculator is like a bit newer, or if it has like more than one line in its display, you'll be able to just write it like it's written. So my calculator, I can go 15 cosine 27 and then just hit equals, and it's going to give me the length of that side, so 13.36. It asks for the nearest tenth, so 13.4. And we don't have any units, so we'll just leave it there. There we go. So that is an example of finding a side using the cosine trig ratio. The next example, number 5 here, remember when we're trying to find the angle, we must use shift or second. You're going to end up with cosine of -1. You've got to use the inverse cosine to get the angle given a ratio of sides. Okie dokie. I'm going to just jump into the sine practice. So this is the additional practice from the course. So this is the sine questions additional practice. I just want to see if there's any tricky ones. Let's do a couple of these word problems because the learning guide doesn't have them until next day. Ooh, I like this bridge. This is a nice one. A pretty picture. Determine the length of the longest guy wire, and guy wires are just these wires on the bridge. It's just what they're called. To the nearest whole yard, if the tower in the middle of the bridge is 75 yards high and the angle of elevation for the guy wire is anchored to the top of the tower is 42 degrees to the nearest thousandth of a yard. Whew! Seems like a lot, But let's see what we can do. So let's take some information from the question. We know the height of the tower, so let's draw the tower. The tower in the middle of the bridge is 75 yards high. So here's my tower in the middle of my bridge. It's a great looking tower, and it's 75 yards high. Don't get thrown off by the fact that this is in imperial, because it just doesn't really matter. The angle of elevation for the wire is anchored to the top of the tower is 42 degrees. So if I take my wire, draw it, it says the angle of elevation, so this angle here is 42 degrees. The question isn't asking for how far is the anchor, the wire anchored away from the guy wire. It's asking how long is the wire. So I'm going to call that X because I don't know what it is. And that's what I'm trying to find, how long the wire is. Okay. We're going to treat this like any other problem we've done so far. What I'm going to do is I'm going to just draw in a little 90-degree angle here. And I could maybe just highlight my triangle here in green, although it's not going to show up super well. But I do have a right angle triangle. So there we go. There's my right angle triangle. If I think about the longest side, or the side that is across from my 90-degree angle, that's going to be my hypotenuse. And then I have my angle, which is 42, and if I went straight opposite that, I end up with my opposite side, which is this 75. And then I have the adjacent side down here at the bottom. I don't know it, I'm not trying to find it, so I don't really care about it. It does look like the Vancouver Bridge before they opened it, and I would think it would be the Vancouver Bridge. Is that the new Port Mann? Is that what it's called? I'm not a lower mainland kind of person. Taylor, you live in the coast. Is that the Port Mann or the something else? Golden Ears? Yes, Port Mann. Perfect. All right. I go back to SOHCAHTOA. SOHCAHTOA. I have my opposite. I have my hypotenuse. I'm trying to find it. So opposite and hypotenuse is the sine. And we're in the sine section, so that makes sense. So the sine of my angle is going to be the opposite length divided by the hypotenuse. Okay, the angle I have here is 42 degrees, so I'm going to plug that in. So I'm going to take the sine of 42 degrees. The opposite is 75 yards. And I don't know what the hypotenuse is, but I'm going to find it. Now, so far we've done this calculation in 2 steps, getting the x to the top and then moving the sine 42 to the other side. I'm going to show you something you might have learned before. If this just confuses you, I'll do it both ways. Put a little squiggle here. If you think of the sine 42 as being over 1, what we can do is cross multiply. I have a feeling probably some of you have seen cross multiplication before. What we do is we take the top of this side and multiply it by the bottom of that side, and we take the top of this side and we multiply it by the bottom of the other side. Do you want to give me like a yes, I've seen cross multiplication before, or no? Just so I kind of have a bit of a reference for how we're doing on this stuff. Yeah. Last year, yes, yes. Cool. I think some of you have probably seen it. Anyways, let's just, let's do it. So we're going to get the x times the sine of 42. (42 degrees) is equal to 75 yards times 1. So if that makes sense, perfect. If it doesn't, that's fine. I'll do it the other way as well here in a second. I'm going to divide both sides by the sine of 42 degrees. And remember, the 75 times 1 on the top is just 75, so that's not going to be anything to be too concerned about. Sine 42 divided by sine 42 is just going to give me 1. And I'm going to end up with x is 75 divided by the sine of 42 degrees. And I'm going to plug that into my calculator and figure out what it is. Sine, I go 75 divided by sine 42. This is where having a sort of newer calculator makes life a little bit easier. What did it ask for the nearest hundredth of a yard? So 112 point, there's my tenths, 0.9 yards. If you have a backwards calculator, I'm not saying it's like backwards is a bad thing, it's just it wants you to put in the angle and then hit the sign and then go from there. You're gonna have to probably do it in sort of 2 steps in your calculator. You'd have to go 42 sine, figure what that is, write it down, and then go 75 divided by, and then plug the other number that you just calculated in. You got 0.6691. Now, we're trying to figure out the length of this wire, and we know the tower's 75 yards tall, so we know that if we ended up with 0.6691, that we probably, unless you're talking about the sine of 42 degrees is, I think that may be what you're saying there, Taylor. Yeah, so perfect. I could write it as a second step here. I can just maybe squeeze it in, 75 divided by 0.6691. So you just need to go 75 divided by that, and you end up with the 112. I said I was going to do this the other way, so if we have sine 42 degrees is 75 divided by x, I'm going to multiply both sides by x. So I get x times the sine 42 degrees is 75, because x and x divide out to give me 1. And then I'm going to divide everything by the sine of 42. You can see that essentially they're the same steps, but just kind of a different way to think about it. And 75, but sine 42, and I said I got point divided. It might be just how you need to enter things into your calculator, Taylor. You'll probably need to maybe do it in 2 steps instead of 1. Your calculator probably isn't remembering the division. It's just, you might have to hit enter again, perhaps. Again, it's just kind of mastering your calculator. Everybody's going to be a bit different with that regard. Okay, so that's sine. Maybe I'm going to just jump into the cosine extra practice. Is there anything that, before I do that, is there anything that anybody's confused about, not understanding, something I mentioned in the lesson that didn't make sense? Okay, hitting it twice works. Perfect, that's good. So again, kind of the battle here is learning how to use your calculator sometimes, which seems kind of weird, but that just kind of how it works. So stuff from the lesson, things you wanted to go through. If not, I'll just do a couple more problems from the cosine, and then I'll give you guys some time to work on the learning guide. I don't see anybody. Oh, maybe Abby has a question. Could you remind me when to use the -1 and when to use the regular one? It's a good question. When we use the -1 or the inverse sine or tangent or cosine, it's when we're finding the angle. So if you think kind of back to if we look at some of these tables, I think the tangent one was a little bit bigger from yesterday. Your calculator needs to be told that, hey, I'm giving you a ratio of sides. I need you to give me an angle, because when you hit the sine button on your calculator, or the tangent or the cosine, all your calculator does is say, okay, I'm going to get an input of a ratio of sides. So it's thinking it's getting this column, this like ratio column, and then it's going to spit out, sorry, your calculator thinks it's getting an angle and it's going to spit out a ratio at you. If you wanted to do the opposite, if you want your calculator to think backwards, you need to say, okay, calculator, I'm not giving you an angle this time. I'm giving you a ratio of sides, and you need to give me the angle. So you're telling your calculator, giving it the ratio, and you need the angle. So if you're trying to find an angle, you're going to use the inverse. If you're trying to find the side length, you already have an angle, so you're just going to put the angle in. Calculators like, yeah, just leave it at that before I confuse myself or you any further. Yeah, I can give you, I guess you guys have about half an hour right now to, you can do the learning guide up to the end of page 4 is what I'd like you guys to work on. I'm just going to look at maybe one question from the cosine, extra practice, and then you guys can have the last sort of 20 minutes to work away on this stuff. Give you some time. So given the following lengths of right triangle, find the unknown angle to the nearest hundredth. For homework, sorry, for homework you're going to watch the third video, yeah. The third video for homework, we're going to spend some time doing the questions in class next day. Then we'll probably do a review type day on maybe Monday, and then you guys can do the test on Tuesday next week, hopefully. All right, let's just do number 5A here real quick, and then I will let you guys have some time to work. My 90-degree angle's here. That makes this my hypotenuse, which is also the longest side. You can see I have theta here, which is the angle I'm trying to find. This question asks, if I go to the opposite side, that's right there, and then I'm given this 8, which forms the angle with the hypotenuse, that gives us the adjacent side. Okay. In the question, I have the hypotenuse is given as 11. I have 8 as the adjacent. And the opposite, I don't have, and I'm not trying to find. So if I think back to SOHCAHTOA, what am I doing? I have the hypotenuse, and I have the adjacent. So I'm using my cosine. So the cosine of my angle, which I'm trying to find, is going to be the length of the adjacent side divided by the length of the hypotenuse. I'm going to plug all the information in. I don't know what the angle is. That's what I'm trying to find. The adjacent side has a length of 8, and the hypotenuse has a length of 11. I'm going to just maybe do some different notation here. I'm trying to find the angle, which is the inverse cosine, because I'm trying to find an angle of 8 over 11. See if you can plug it into your calculator that way, if you can figure out how to do it on your calculator. Some of you, if you have an older school calculator, you might have to go 8 divided by 11 and then go inverse cos, or second cos, or shift cos. My calculator is a little bit newer, so I can go second cosine and 8 divided by 11. If I put the 8 and 11 in brackets in my calculator, I'm going to end up with 43.34 degrees. One problem that you're going to run into with your calculator is if you go inverse cosine and then you hit the 8 button, what your calculator thinks is, okay, take the inverse cos of 8 and then I'm going to divide that all by 11, which doesn't really work. Your calculator is not as smart as you. So when you do it, what you need to do is if you have a calculator that allows you to put in brackets, you put it in brackets. So inverse cos 8 divided by 11 in brackets. You should end up with 43.34. Okie dokie. I'm gonna leave you guys there, and I would like it if you would finish off the learning guide to the end of page 4. You have about 20 minutes to do that right now. Hopefully you've got a good sort of foundation understanding of this stuff. Reminders, midterm number 2, January 18th, Monday, Central Gym, 9 o'clock. There is essentially one lesson left. It's kind of where everything comes together for this trig stuff. So watch the video, the third video from the course. Bring it up here. There's 1, 2, and 3. So Math 8, lesson number 3, Unit 8, lesson 3. You can watch that for homework. We'll spend some time doing problems the next day. And that's kind of it for this stuff. So thanks, guys. We have math help today. If you want to come in, Mrs. Parker and myself will be available from 1 to 3. And hopefully you guys come cross-country skiing on Friday. Have a good one. We'll see you tomorrow.